Hello, this is the lesson for Unit 17, Lesson 1. This is translations in a plane. So translations in a plane is something that you should have already seen, but we've got a couple of little twists that you need to see with this. All right, if you've got any idea that you may have a question about anything that's in here, make sure you have a piece of paper and something and a writing utensil like a pen or a pencil to write it down so you can bring your question before we start tomorrow. And so let's go ahead and begin this. Okay, so a translation is simply a transformation of an object or geometric figure in which the object is simply moved without being rotated or deformed, or what that word means, changed in any way. After being moved, the object is congruent to its original self. Okay, these terms are all synonymous for translation. Okay. Sometimes you'll hear it called a move. Sometimes you'll hear it called a shift. Sometimes you'll hear it called a slide. But the official one that you need to refer to it with is translate. Okay, translate or translation, that is the official terminology for this particular type of movement. All right, so the translation of an object so that it is congruent to its original self is but one example of a rigid motion, which is an isometry. The next two things after this, the rotation and the reflection, as well as the translation, are all isometries or rigid motions. That just means nothing changes other than the position. Okay, which of the following is a rigid motion translation of this object? Okay, so we have the triangle sitting here in the first quadrant. Okay, so we need to find something in these next five things that tells us that it is the same thing, that's in the same relationship. In other words, the point is in the same direction and everything else, and is the same size. Okay, so as you can see here, the only one that didn't change its size and everything else or rotate or anything like that is answer choice B, which is the correct one here. Okay, there are some more definitions of things. Without showing the translation of an object on a graph, in other words, without graphing it, it is possible to indicate in writing that the translation using either of these two conventions. Okay. All right, so the first one is the most common one, which simply says the point xy is translated so that x is moved to the right 2 units, which is the plus 2, and it's also moved in so that the y goes down by 5 units. Okay. An equivalent way of saying that is t with the subscript of the point or the notation 2 comma negative 5, which means you add 2 to the x and subtract 5 from the y. Both of these indicate a translation of 2 units to the right and 5 units down. Okay, so example 2, they want us to perform a translation of the points shown here according to xy translated x minus 6, y plus 3. So this means we're going to subtract 6 from the x and add 3 to it, to the y. So this means we're going to go to the left 6 and up 3. Okay, so we can do that just by counting the boxes. So if we come across, this becomes negative 6, and plus 3 puts us here at the point negative 2, 1. Okay, so this is where it should show up. Okay, this time they want us to translate a triangle. So the thing to do is to go to each one of the vertices of the triangle and perform the translation that they've got here, which says they want to go to the right 3 and down 2. So this point up here at the top will go across 3, so it will be at 1, and we go down 2, so that puts us at 1, 2. And then you do the same thing to the point down here on the left and the point down here on the right. Connect them up, and this is what you should end up with. All right, Then we'll continue on here. So under the translation, xy translated x minus 8, y plus 2, the point 5, negative 9 becomes which of the following points? So we put the 5 in for x, so we have 5 minus 8, which is negative 3. Negative 9 plus 2 gives us negative 7. So the answer choice here should be D, which is negative 3, negative 7. Okay, example 5. Under the translation, negative 6, 23, point A becomes A prime, which is 18, negative 29. So what they've told us here is they've told us the result of the translation. They want us to go backwards and find the original point. So that instead of doing what it says here, we're going to subtract each of these from the number that was the result. Okay, so this becomes 18 minus negative 6 is equal to 18 plus 6, which is 24 for the x. Okay, so the other one for the y becomes negative 29 minus 23 equals negative 52. So the point that you should have as the beginning point is going to be 24, negative 52. All right, example 6. Describe the translation that would move A, B, C, D to A prime, B prime, C prime, D prime. Okay, so the way we do this is we count from A to A prime and see what we have. So the first thing I would do is go across 1, 2, 3, 4, 5, 6. That took 6 to get to the right underneath the A prime. Then count how many going up. So it's 1, 2, 3, 4, 5, 6, 7, 8. So the translation here will be 6, 8, because we went 6 to the right and up 8 units. If I want to check it myself on it, then I do the same thing for B and B prime, or C and C prime, or D and D prime. If I get the same result both times, then that's pretty sure that's what I'm going to get. Okay, just as geometric objects can be translated, the graphs of relations can also be translated. And this is something you're going to get into in Algebra 2, especially when you get into things like the inverse and so on and so forth. Okay? So to perform the translation THK, you're going to replace all the x's in the original relation with x minus h in parentheses, and replace all the y's in the original relation with y minus k in parentheses. So the example 7, what they want us to do is they want us to write the equation that results after y equals parentheses x minus 7 in parentheses squared plus 2 undergoes the translation T6 negative 11. So this means that we're going to put in for every y, we're going to have y minus negative 11, and x is going to have x minus 6 substituted for it. So we have y minus negative 11 is equal to, and I'm doubling the parentheses because I'm putting a parentheses around the x minus 6, and that's minus 7. The whole quantity gets squared plus 2. So this becomes y plus 11 equals x minus 13 in parentheses squared plus 2. Okay, all I did here is do the simplification. The negative times the negative gives me the positive. The negative plus the negative gives me the negative 13. Okay, like I say, if you got any questions about this, then be sure you get them written down, bring them to class tomorrow. I will be more than glad to answer them before we actually start any kind of work on this. So this concludes Unit 17, Lesson 1. Thank you very much. See you tomorrow.